So this is Akshay with another video here, and this time around this video is going to focus on the advantages of parallel combination over series combination. Before just entering into the discussion, let me tell you that is the parallel combination is far more advantageous than the series combination. This question is far more important as far as board examinations are concerned. Frequently this question is being asked in many ways in examination. So let us try to understand the advantages of parallel combination, but at the same time we are going to understand the disadvantages of series combination. So let us begin here. Remember, these are the disadvantages meant for series combination, and these are the advantages meant for parallel combination. Only 5 points you have to keep in mind, and then you can easily expand them over there. So let us start with first point here, pathway. That is the way for the current to flow through. In series combination, as you are well familiar with the circuit diagram meant for series combination, that in series combination current has got only one pathway to flow through, and that makes the point here, you can say that makes a sense as far as the disadvantage is concerned. That is, since current has got only one pathway to flow through, it means if one of the electric components got defective, then the current can't pass through the next electrical component. It means this very, suppose it is a bulb, this bulb will stop functioning, though it is quite okay there, because it is not gonna get current. Now question arises, why? Because current has got only one pathway to flow through. Since this you can say a bulb or this resistor has got defective, it means the current can't go to the very next bulb there, and that's the drawback we can understand in series combination, thanks to the only one pathway for the electric current to go through. So that's the first thing. Over the parallel combination we are gonna budget, it has got multiple pathways. Number of pathways equal to the number of resistors. How many resistors you are taken, those number of resistors will tell you the number of pathways. As it is crystal clear from this kind of a circuit diagram, that is, we have taken two bulbs or two resistors here. One is R1, another one is R2, and these both resistors are connected in parallel combination. And you can see, as you have learnt in detail in both the parallel and series combination, that in parallel combination current got distributed amongst the number of resistors. Here it is the same, the current got distributed amongst these two resistors here. I1 current flows through R1, I2 current flows through R2. But does it mean? It means if this R1 got defective, then what happens to the, you can say, other resistor, or what happens to the other bulb? Suppose it is bulb, then what's gonna happen? It will keep working. It doesn't stop, because of the reason that current has got another pathway to flow through, thanks to the multiple paths it has got. That is the, you can say, the advantage for the parallel combination, that since current has got many pathways, many ways to go through, it means if one of the electric components got defective, then others will keep functioning as it is. Suppose it is a bulb, if it got fused, then what's gonna happen? Will this bulb stop functioning? No, because it will keep getting the current. Why? Because current has got many pathways to flow through, and that makes advantages for ourselves. And you have noticed in your own home that if one of the bulb got fused, then what's happened? All other, you can say, that is bulbs or tube lights keep functioning, because all those electric components have been put in parallel combination. Every electric component has got a different pathway for the current to flow through, so it is not dependent upon the working or non-working of other electric appliances. So that is the advantage for the parallel combination. Come to the number 2 point, that is switches. Remember, switches are always put on the live wire through which current flows, because you are gonna on and off and current flows through the live wire. It means every switch is going to be put on the live wire. When it is current has got only one pathway to flow through, it means the switch is gonna put on that very pathway. Switch is gonna put on that very live wire, since it has got only one wire for the current to flow through. It means there is only one switch available in series combination. So but does it gonna affect the, you can say that is this combination as a whole? Means you can't switch on or off the resistors independently. If you switch on, then all the bulbs will keep shining or glowing. If you switch off, then all the bulbs are going to be off there. None will glow, none will give out light there. That is another drawback, because only one switch is available there, thanks to the only one live wire it has got, because current has got only one pathway. So that is the disadvantage number 2 for this very series combination, that if you can't switch on any electrical appliance independently. But what is the story over here in parallel combination? Every resistor has got its own switch, multiple switch. Multiple switch means number of resistors equal to the number of switches. So it has got its own switch. It has got its own switch. It means you got the independence to switch on or off the given electric appliance as you do at your home. If you want to switch on tube light, you can. If you want to switch off TV, you can switch it off, because all those electrical components have been put in parallel combination, A, and B. In parallel combination, every electrical appliance has got its own switch. Why? Because in parallel combination, number of resistors equal to number of pathways for the current to flow through, and number of pathways for the current to flow through is equal to the number of switches. So every resistor has got its own electric switch, which gives a kind of a freedom to every resistor to get switched on or off the way it wants. So you can switch it off or on as you like, and that is the advantage for the parallel combination. Now third is the resistance. We have learnt it before, and in detailed analysis of the resistances, that what's gonna be the resistance low or high, you are directed to visit my previous videos. In-depth analysis have been done over there. That is, resistance goes high in series combination. And what happened? Resistance goes high. What does resistance do? Resistance oppose the flow of electric current. It means it will oppose the flow of electric current. And what's the drawback of that? Means the electric appliances, for example, high power rated electric appliances which require more current for their proper functioning. High power electric appliances like air conditioner, electric geyser, refrigerator, water heater. These are the high power rated electric appliances which need more current for their proper functioning. Those electric appliances in series combination will not work properly. Why? Because those electric appliances do not get appropriate and the right amount of or required amount of electric current for their proper functioning. Why? Because the resistance in series combination is very high. It means more the resistance, more the opposition to the flow of electric current, and that shows that each and every resistor will not get the appropriate amount of electric current for their proper functioning. And resistance is high because you can understand here it is just like a traffic. Vehicles are running through one lane, one single road. So there would be more and more opposition, right? And here in case parallel combination, the resistance is low. Why? Because the traffic or the vehicles, number of vehicles has multiple choices. Vehicle can go this way, vehicle can go that way. There are number of choices. It means hindrance or opposition to the, you can say, traffic is going to be very, very low. And that's why resistance in parallel combination is low. And this is what we can understand by taking the traffic of a single road as well as a highway. you can run your vehicle at a greater speed on the highway because there is lesser amount of hindrance because multiple lanes are available there. But when you are traveling on a single road, resistance is far more greater, and that's the scenario in the series combination. So in parallel combination, resistance is low, and mathematically you can understand, and rather you have already understood in my previous videos, mathematically the resistance in parallel combination is always low. So overall resistance is low. What does it mean? The lesser opposition for the electric current, it means current can flow in parallel combination smoothly. And if current can flow in parallel combination smoothly, it means even the high power rated electric appliances like electric geyser, air conditioner, water heater, etc. will get the required amount of electric current because current has got lesser amount of opposition in the parallel combination. Another point here, the bullet point, next one, additional component. If you add additional component or additional resistor in the series combination, it will increase the resistance far more further there. More resistance is gonna become there if you are going to add additional resistance. I am adding another resistor here. Okay, it is already 2 ohm and 2 ohm. 2 ohm. Total resistance comes out to be 4 ohm. Here it is, and suppose one more resistance being added here. So what's gonna happen? Resistance is not gonna fall down, rather it's gonna increase here, and it is how much? 6 ohm, because R is equal to R1 plus R2 plus R3. It will become 6 ohm. Come over here. In case of parallel combination, suppose you need to add another bulb for your lighting purposes, then what's going to happen? It will decrease the resistance even further. More resistance, there would be a greater fall in the resistance, and we can take it by mathematical way here, because one way is that when you are going to add bulb here, suppose you have attached a bulb here, so what's happen? Will the resistance increase? No. In parallel combination, resistance will fall even further. Why? Because current has got another path to flow through. So multiple paths means lesser opposition for the current to flow, and hence lesser opposition means current can easily flow through the you can say a circuit there. And we can take the example, let it be 2 ohm, and it is 2 ohm, and the resultant resistance is equal to the reciprocal 1 upon R is equal to 1 Rp, 2 plus 1 upon 2, and it is 1 upon Rp is equal to 1 upon 1, and this implies that Rp is equal to 1 ohm. This is the resistance, total resistance when you are taken 2 ohm resistor. Suppose I have added another resistor here and having the same resistance, then what's gonna be the total resistance of these three resistors? Let us have it. 1 upon Rp is equal to 1 upon 2 plus 1 upon 2 plus 1 upon 2, and it is 1 upon Rp is equal to 3 upon 2, and therefore Rp, this goes up, this comes down, and it is 2 upon 3 and 0.6 ohm. You can match here. It is 1 ohm total resistance, and when you have added extra resistor, it even falls further. It becomes 0.6 ohm. So additional component will not increase the resistance, even it will decrease further there. And that's another advantage for the parallel combination. And the last and final component is potential difference. Potential difference you have learnt in in-depth analysis of series as well as parallel combination, that potential difference got distributed in series combination. What does it mean? That is, suppose it is 220 volt, that not a single resistor will get 220 volt here, neither R1 nor R2, because both are being put in series combination. It means in series combination the total voltage got distributed. It means none will get the appropriate amount of voltage. That means that their working will be, you can say, hampered badly. Not a single resistor will function properly, and even you have, suppose you have got high power rated electric appliances, those high power rated electric appliances will not get the appropriate amount of voltage and they do not function properly. A and B, even it will, you can say, that is damage the electrical appliances which are running under the low voltage or potential difference, because in series combination voltage is got distributed, not a single resistor get the appropriate amount of voltage, that is the total voltage of the main supply line. But in parallel combination, here is a bigger advantage as well. In parallel combination, each and every resistor will get the same voltage as that of the main supply line. Suppose it is 220 volt, it means all these bulbs will get 220 volt voltage, and that makes sense here that every electric appliance will function properly because they are getting the appropriate amount of voltage. It means appropriate amount of voltage means they will get the appropriate amount of current required for their proper functioning, and that is the another advantage for the parallel combination. So these are the advantages for the parallel combination over the series combination. And since you have noticed here that is parallel combination is overpowering the series combination, and hence we can conclude here that parallel combination is far more advantageous than the series combination, and that leads you to the direct conclusion that is, yes, in domestic circuit it is the parallel combination which does the trick and not the series combination. That's it here.